All right, welcome to your free GMAT Prep Hour. I'm Dmitry. Today's focus is going to be on quant accuracy and specifically how to use multiple choice to make things go better. Um, I've been meaning for a while to do a workshop where we talk more about accuracy because I think a lot of people over focus for this test on doing the hardest questions and getting the hardest things right. I don't know how hard you'll find the questions today. Some of them you might think are quite easy, some of them you might not. Um, but I'm less worried about difficulty and more worried about how do I make sure that if I can do the question at all, I get it right. And that if I'm struggling with the question, I still find ways to maybe narrow things down a bit and increase my chances of getting it right. Because of course, in the end, what we want to do is we just want to get as many right as we can, but we also want to make sure, because it's an adaptive test, that we're catching the easier questions. And what I'll say and say again, and it just really bears repeating, the harder a question is, the less important it is. And I really want to emphasize that. So the most important questions that you see are the easiest questions you see, because those are the ones that really pull you down if you miss them. If you miss a super hard question, cool, guess what? So did everyone else. That doesn't make a big difference. But if you miss a question that's easy or even easy in big air quotes, right? Maybe it's not that easy, but if you miss a question that like the majority of people are getting right, that really hurts you. But even if you're dealing with very, very hard questions, maybe you're trying to move from, getting a 48 quant to a 50 quant or something like that. Great. How do you make sure that you're just avoiding error? Right. And that's like a big part of this test. And so one of the things that we can really emphasize is that this is a multiple choice test. That's not all there is to it. There are specific strategies for different kinds of questions and different content. A lot of it comes down to how you organize your scratch paper. Are you writing down what you want? Are you taking account of variables? Right. I almost missed one recently just because I overlooked what a lot of us overlook, that it said that something had to be an integer, and I was looking at fractions and no, just integers. So it's how do I make sure that I'm noticing those kinds of things? But the beautiful thing about multiple choice is that it catches a lot of our errors anyway. Um, if I get an answer of 2.5, but there aren't any fractions in the answers, then I know that I've missed something, and I can use that to, sort of redirect myself. And the GMAT is surprisingly nice sometimes in that they don't put every single trap answer you might possibly have come up with. And so a lot of the mistakes we make will catch because the answer is not there. And I think that's a easy thing to forget about a multiple choice test. It's working with what we have. So in other workshops, we've talked about specific strategies like working backwards from the answers or estimation. And we'll talk about some of those things today. But I want to talk more broadly, and I want to focus more broadly on just what can I learn from looking at the answer choices of a question? What does that tell me about approaches that I might take? Ways that I might reduce error, or make things easier on myself. So that's really what I want to focus on a bunch of multiple choice problems is how do I make it more likely that I get it right? Regardless of how easy or hard it is to do the problem. So some of these you might look at and say, oh yeah, he's doing this, cutesy thing, but this is a really easy problem for me to solve. I don't care about that, right? I'm not trying to give you the hardest problems you'll ever see, although some of them I think are hard. Um, I want to worry less about can you do this the normal way, and more how do you eliminate answers to reduce error so that if this were a hard question for you, you would get it. So let me give an example. This is a problem that some of you might find challenging and some of you might think it's just not very hard. But I don't want to worry about the regular solution. I just want to look at how we can narrow things down. So I'm not going to give you a full 2 minutes like I normally would to do this problem. I just want you to read it over for a moment and think about, are there answers that don't make any sense? Are there answers that seem impossible? Are there answers that seem likely? So just take, like 40 seconds or so to read this over, then we're going to talk about it. Okay, so looking at what we've got, they've given us some money to redistribute to some people, and they want to know about maxing out the median. So min-max problems often involve, both ideas. If I'm going to maximize one thing, I'm going to minimize something else. If I'm trying to be greedy and take as much as possible for myself, I'm going to minimize what everyone else gets. That might not be all the way to zero. There might be some constraints on that, right? A greedy business owner still might have to pay their workers a certain minimum, right? Minimum wage. They can't pay them zero, but they pay them as little as they can because they're being greedy, and that's what we do with a maximization problem. So do you see any answers here that don't make sense or that seem unlikely? 202. What's wrong with 202? 202 is the same as our total, right? There's $202. If we add this up, it's $202 to play with. They never said that one person couldn't get all the money, but that couldn't be the median person because how would someone else have more? Right. So that gets rid of one answer. It might imply even a way to solve the problem. But at the very least, we want to get rid of that. Any other answers that you're kind of looking side eye at? Any other answers that you might cut? A and C, James. Okay, why those? They're in the question stem. I don't think that proves them wrong, but it might make you suspicious of them, right? Um, Specifically, I'm especially suspicious of 72 because that's the median now, and it would surprise me if there was no way to improve it, right? So I'd be very nervous about this. I see what you're saying on C. It's probably not just one of the answers, one of the numbers from the question stem, but I can't prove that yet, right? But I get what you're saying. I would be very nervous about A, and I might even cut C, or at least shy away from it if I was going to guess, right? So let's think about 72 then for a second. We know that the median could be 72, right? Because we could have 32, 72, 1, and 98. But they're saying that's the maximum in A. How can we very quickly disprove that? What could I do to increase the maximum? I'm sorry, what could I do to increase the median, right? What if I just took one away from this one, gave it to this one? Can I do that? Seems like I can like I can redistribute it a little bit, and that already has now disproven A, so I can now confidently cross off A. So what's the limit? Can I keep going? How long can I keep going? Could I give all of the first person's money to the median? What if I did? What if I gave away all this person's money? Now I had this. Yeah, I'd have to get it to match the largest because right now the middle number is bigger than the largest number. So I could reorder that. I could say, oh wait, no, I can't have that, but I can have 0, 98, and 104. And look what I've just done. I've proven that it can be 98. So I get rid of B. B is not the maximum because I can get 98. Could I make the median any bigger? Well, now I could even these out, right? I could do 0, 100, and 102. Okay, I've already gotten above 98. It's going to have to be D now because if it's more than 98 and 100 isn't the answer, it's got to be the next one that there is, right? And of course, if I give one more away, these are the same. That doesn't stop 101 from being the median, right? 101 is still the median value. Okay, so this is one way to do that. It's not even necessarily the easiest way to do it. You might have a way that's faster than this. But what I'm suggesting here is that part of my process when I'm doing these things is to start thinking about what answers are reasonable, what makes sense, what I can eliminate. Sometimes that leads me into a solution. Other times I just look at it real quick and that's it. And I've really tried today not to cherry pick the problems. And what I mean by that is sometimes there are problems where there's only one answer that makes any sense at all. And at a glance, you could just say, oh, I need an even number, so it's E. Or I need an answer that's smaller than 40 and only A is smaller than 40. Or, I'm averaging two numbers that has to be between those numbers. So these are too small, these are too big, it's B or it's whatever. That's nice when it happens, but that's the exception to the rule. It's not what usually happens. So I tried not to cherry pick. Certainly, I chose questions that would be interesting to look at the answers on, but not ones where we could just solve using the answers really quick usually. And so it's not necessarily that you have to do it this way. You might just as well have said, okay, if the total is 202, right? If I want to, max the median, I might just, min the first, right? So I could say, okay, if I have 0, and then for these two, I have 202. And then to make the median still in the middle, I can't give it more than half. So then I have 101 and 101. And if you think of that, that's great. But notice that was a little more theoretical. I'm having to think about, what I would do. And that might not occur to you right away, right? You might try something else first, right? For instance, you might say, what if I distribute them evenly, right? If I have $202, well, that doesn't distribute very evenly. But it's about what, like 67-ish each. So clearly that's not the answer. I can clearly have more than that. And that's where you might try this kind of redistribution thing we have here. So I say, okay, distributing them evenly clearly doesn't maximize the median. So what does, right? In one way, it's close because doing them all the same means that the median and the max are the top are the same, I should say. But then I need to take away from the bottom one, right? And that's where I make the idea of splitting it all between the second and third people. Okay, thoughts or questions on that one? Okay. And watch out, some people might miss this because it might make an assumption that the numbers all have to be different, and it never says they have to be different. If they did have to be different, then we would need to have assuming integer amounts of money, which they didn't say, that would be, so like that's one thing. Let's say I had done this. Let's say I assumed they had to be different. And so I did 0, 100, and 202 because I thought I couldn't do, or not 202, because I thought I couldn't do 101, 101. But two things there. One, this answer is not there. It disproves ABC if it's at least this much, but the answer is not there. And two, well, why couldn't I then have a decimal like 150 cents and 101 and 50 cents? And if I can have that, why can't I have 100.9 and 101.1, right? And so then I have to start saying, wait, did they ever say they have to be different at all? And so one thing I can notice again working with the answers is if I notice the answers are all integer values, then it must be that the right answer is a precise number. And if I see that my answer of 100 isn't there, that's a sign that I've done something wrong. And so watch your assumptions sometimes. Okay. Let's do a different one. This is obviously one where we could spend a lot of time doing some busy work, right? And so someone who's just like a dutiful student will just expand all these out. Okay, x minus 2 times x minus 2, and x minus 1 times x minus 1, or x plus, okay, da, 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 da. Work it all out and cancel all the terms. But the GMAT doesn't tend to center around busy work. So again, just take like, I'm only going to give you like 25 seconds. Just think about what you might do with this, what options you have, and think about if there are any answer choices that don't make sense, or if there are any clues you can get from the answer choices about what's expected from you on this problem. So just take a moment to look it over, then we're going to talk. All right, so kind of, I hesitate to use the word cheating, but kind of cheating off the answer choices. Is there anything you noticed that we should be looking out for in this problem, or did the answer choices suggest anything to you? One thing I might look at is that first term, right? Some of them just say 5x squared, right? Or 5x squared plus 10. Then I have 5x squared plus 6x. I have a lot of 5x squared. I have 1x squared. So I might think about, if I did this workout, how many x squareds would I have? Would I have one or would I have five? And Maria's saying I need to have five. Why? We're adding them, and each of them will have an x squared, right? I might not, be the fastest with quadratics, and I still might recognize that. You might also get something from just expanding out the first one. If you don't know, right, the pattern that they're testing here is this one, right? That if you take an a minus b or whatever term you want squared and expand it, and if you haven't memorized this, like absolutely memorize it. Square of a difference, square of a sum, difference of squares. Those three quadratic patterns central to know on this test. You just want to have them at your beck and call. But the idea is when you multiply it out, you'll have a times a, and a times negative b, and negative b times a, and then you'll have negative b times negative b, so you'll get a positive term there. So you end up with something that looks like this. So in this case, if I expand out x minus 2 squared, I'm going to get x squared. Get minus 2x is minus 4x. And then minus 2 times minus 2 is positive 4. So I'm going to get this. And so my a here is x, and my b is negative 2. So I've got a squared minus 2ab minus 2 times x times 2 minus, or well, plus 2 times 2, negative 2 times negative 2. So we have this. So this is going to have an x squared. This will have an x squared. This will have an x squared. This will have an x squared. I've got 5x squared. So I can get rid of C because I need, whoops, I need 5 of those. So that's something. Okay. Now I might think about the other terms. How much of the rest is going to cancel? If I look at this first term, is this going to cancel with anything? Is this going to cancel with anything? So if I keep expanding the rest out, will all my x terms be negative? Will some of them be positive? What about this term, right? Let's look what happens when I do x plus 2 squared. The x times x is the same, right? That's another pattern. But the middle term becomes positive, right? So that's this other pattern that you want to know, which is if I have a plus b squared, that's a squared plus 2ab plus b squared. Again, if you haven't memorized that, memorize it. Okay, so when I put these together, what happens? Add these up. We already predicted what was going to happen with x squareds. They're going to add up. We're going to end up with 5 of those. So I can kind of ignore that, but I do get here 2x squareds. Those add up. The 4x and the negative 4x, poof, they're gone. And the numerical terms add up. We just get 8. So we can see that we're going to have some x's adding up to nothing, right? Some x's cancel, I should say, whereas we're going to have our numbers adding up. What answer does that suggest to you? It's probably going to be right. What happens when we do the same thing for the minus 1 and plus 1? And what happens then when we do the x squared, right? We don't automatically, we haven't yet proven that we need a plus 10, but plus 10 is all we have, right? So it looks like there's going to be a plus 10. It doesn't look like all the numbers are going to cancel out. The only way the other numbers would cancel out is if there would be some negative numbers, but there's no way to get a negative number, right? If I square x plus 1, I'm certainly not going to get a negative. If I square x minus 1, I actually won't get a negative either. It's this pattern, the plus. So notice that whichever form I'm using, this part, the plus stays consistent. The plus of the number stays consistent. So I'm just going to be adding. And all these have a plus 10. Whereas the middle term cancels. So I need that plus 10. Now that's in 3 of the answers. But what I might also predict at this point is, look, the x squared term is not going to have any extra. And the -1 and +1, well, guess what they're going to do? They're going to do the same thing as before. So I don't have to do it all out. I can. X minus 1 squared and x plus 1 squared are not that terrible to do. It's going to be x squared minus 2x plus 1 and x squared plus 2x plus 1. But the idea is that the x's are going to cancel out again. So if those x's will cancel out and these x's cancel out, then we're not going to have any x's. And I don't have to do all the work to get there. I could just say, oh, look, knowing my pattern, and this is just classic GMAT, right? Knowing my pattern means I don't actually have to do all the grunt work. I can look at this and say, hey, that middle x term is going to cancel with the middle x term here. And the middle x term here is going to cancel with the one here. And there isn't one here. So there's no x term. There's just an x squared term and there's a number. And the actual number doesn't matter because it doesn't change. Right? It's like sometimes you'll see answers that look like this: 270, 27, 2.7, like this, right? And then I'll have a student miss it and they'll tell me this. It's kind of funny. They'll say, oh, yeah, no, I got it. I just was off by a decimal place. Well, yeah, everyone who missed it was off by one or more decimal places, right? The point is, well, we know the answer is a 27, but where does that 27 go? It's just to multiply by 10, divide by 10, blah, 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 right? And so a lot of times the actual calculation isn't the point. It's what are you supposed to be doing with this? And what other pieces do you have? So I don't need to figure out that these out of the 10, that's done for me. I just have to figure out that the number part stays and the middle part with just a single x goes. That all right? And if you get this right by doing it all out, don't think of that as being right. And I mean it. Don't think of it as being right. If you did this, if you wrote x squared minus 2x plus 4 plus x squared minus, 4x, I said it wrong. 4x plus 4 plus x squared minus 2x plus 1 plus x squared plus, if you did all that and got it, mark it wrong. Because you don't have time for that. Oh, sorry. Unless you did all that in like a minute 40 or something like that. And then, more power to you. But if it took you a while, especially once you get started, count it wrong because you can't afford that in the test. So we got to think about what are things we can do that are accurate that we can really realistically do. And that's really, really important, right? I think about it as like I was just traveling, right? The airline tries to prevent accidents and error and crime and all that, but they have to be reasonable. They have to keep everyone moving, right? So maybe someone at TSA would love for us all to I don't know, take off all our clothes and submit to a full inspection and arrive 9 hours early to be questioned. But they just can't do that, right? For various reasons, they can't do that. And we don't have time to do all the steps, all the things. So you've got to, be very pushy about finding ways around some of those things. And then when you start to look, you often find them. Okay, here's another one. Take 30 seconds to look it over, then we're going to talk. Okay, so what do you see in the answer choices? Are there any answer choices that either seem wrong or that suggest anything about how you might do the problem? For instance, if we look at the answers, 3 of them were dividing by x or by x plus 1, and 2 of them were subtracting an x term, right? And we have 60s and 30s. I don't want to be too quick to say whether it should be 60 or 30. One person might say, well, obviously 60 because that's the number of the problem, but they know we know that, right? Or we could do what James was saying earlier and be nervous about 60 because it's the problem, but 60 is clearly an important number. It could be in the answer. So I don't want to try to reason based on the 60 itself, although obviously that matters. But I might want to think about whether I want to divide or subtract. If I think of it as like an organization can really help too, right? I could say hey, there's a short tree and a tall tree, and the total is 60. I could organize this as, hey, I've got a short tree, and then the tall tree is x times the short tree. So I've got an equation. And honestly, at this point, I could just solve for s, right? And that's not a bad way to do it. But I might think about subtraction versus division even before I do that, because I could say, if I subtract to get the short tree, I'd be subtracting a term with x in, with s in it, right? So I could say short equals 60 minus xs. But do I know that s is, say, 2 or 5? Can I prove what s is? Am I going to find out what s is? Doesn't seem like I have enough information to find out what s is. So these are looking very suspect to me. The ones where we divide by x might not be as clear, but we might think about, hey, if x is a multiple of s, then maybe I can think of the total as being a certain number of multiples of s. And in fact, if I simplify this down, I really have my answer. I just pull an x out of both terms, and then I can solve for s. That gives me that value. So if I've got the equation, then really the algebra is not so terrible at all. But thinking about still what's reasonable might give me a way of thinking about what I'm expected to do. For instance, the answer could have been this one up here. That's not wrong, right? The short value is equal to 60 minus xs. There's two problems there, though. One, they just didn't give it. It's not in the answers. And two, it's not just in terms of x, it has an x and an s. And a lot of people get very worked up about this phrase in terms of, and they get kind of thrown by it. All in terms of means it really doesn't matter that much. It just means that's what's going to be in the answers. The answer is just going to have x. It's not going to have any other variables. If they say in terms of x and s, then x and s will both be in the answers. But your job is not to write the answers. They're there for you already. So you could look at the answers and say, oh, even if they hadn't said in terms of x, if they just said how tall is a shorter tree, you could look at the answers and say, oh, the answers all use x only. So I need to get s out of there, right? Which makes sense. I don't want to define s in terms of s. That's kind of weird. And so that's another reason that, this other one would be, would not be there. All right. Okay. So yeah, in terms of doesn't specifically mean division. In terms of just means that's the variable we'll see. If I didn't want to do algebra, absolutely I could pick numbers. Yes, thanks for asking that, right? So another way I could think about that, and this avoids me having to set up the the algebra or the equation at all. I could just say, I need one tree to be a multiple of the other tree. So I know the total is going to be 60. Give me some heights. What could they be? Okay, they could be 10 and 50. All right. Now, what would that make x? That would make x 5. One is 5 times the other. Notice that's a lot easier than the reverse. If I decided that x were 10, let's say, then I have to say, okay, what's a number where we add 10 times it, you get 60, and it's actually not going to be pretty, right? I'd have something like s plus 10s equals 60, and s is going to be some weird number. It's going to be 60 elevenths. I don't want that. These are my numbers, and I want to make them work for me. I don't want to work with 60 elevenths. That sounds terrible. So find numbers that are easy to work with. Then I say, okay, how tall is a shorter tree? I want to answer the question, so I'm looking for that. And so another accuracy tool is to make sure, it sounds so obvious, but make sure you're giving them what they asked for, right? So at the beginning, make sure you know what they want. Oh, they want the height of the shorter tree. Okay, so at the end, make sure that's what you're getting as your answer. So when I plug in x is 5, I need to make sure it gets 10. The only drawback of picking numbers this way, or one of the only drawbacks, is that you do have to test all 5 choices. Now we know, because we cheated, right? Now we've already done this. We know already what the answer is. So if we get A to work, then cool, we could feel like we're done. But on the real test or on a problem in general, you don't know that. And so you need to test all 5 because there are certain cases where more than one will work. But let's just check. All we need to do is see if they give me 10. I don't need to know what the actual number is if it's not 10. So here I do 60 over 1 plus 5. Oh, that's 60 over 6. Hey, look, that's 10. Yay. But don't just pick it. You got to test all of them. If I do 60 divided by x, 60 divided by 5, hey, that's not 10. I might have to see that it's 12 to know that it's not super different, but you might know it's not 10. 30 divided by 5, hey, even if I didn't know my times tables, I would know that's not 10. Okay, so that's out. Here's 60 minus 10 is 50. Oh, that's the tall tree. That's tricky. If I were looking for the tall tree, I might get turned around and have this. Although if the tall tree had been right, then there should be another answer that worked as well. Whereas here I do 30 minus 25 is, oh, it's too small, right? But again, if any of these calculations were hard, I wouldn't have to do them as long as I could tell it wasn't 10. If I had picked a pair that got me x is 2, then E would have worked as well, right? So that's where I've got to watch out, right? So let's say I had chosen the short tree to be 20 and the tall tree to be 40. There's nothing wrong with choosing those numbers, but then I would get x equals 2. And if I'm trying to have x equals 2 and get an answer of 20, you'll notice that 30 minus 10 is 20, but A also still works. 60 divided by 3 is 20, so I'd have two answers. So here's one where you might benefit. If you had done that, you might benefit from just grabbing A and not moving on, but that wouldn't be so hot if E were the one that were the right answer and A were the one that just happened to match it. So that's why you always have to test all 5. In this case, if that happened, you'd have to either say, does one of these make more sense? Or is there a reason to, or can I just test new numbers? So let's say I had done that. Let's say I had picked the short answer of 20 and the long one or the tall one is 40, got x equals 2, and I was down to A and E. Is there any reason I should have known that E was not right? Well, we kind of already did it, right? We crossed out E earlier because we said, hey, do we know that it's going to be 5 times x? Does it have to be that? Or did this just work out in this particular case and it wouldn't normally work out? And so if I tried some different numbers, A would still work and E wouldn't. And one way I could guess that, or sorry, not E, I should say D, 2 times x. This just happened to work out because 2 matched our value of our multiplier, right? I'm talking nonsense. Sorry, it's E that we're. I always have to do one like the thing like that in each workshop. Sorry. So E is what we're talking about. E is where we have 5 times 2 is 10, and it happens to work out. So if we had already crossed out D and E, then we'd know not to pick those. We'd know to grab A. Right. And every time I garble something, I can then say, see, all these accuracy tools work because I make all these silly mistakes and I still get these questions right when I do them. So, you don't have to be free of error to end up being very accurate on the test. So yay for that. Okay. Let's do another one. Same thing, just take a quick look. What do you see? And the answer is what's worth noticing, what might be due other than just start doing the math. Okay, so I don't think any of these answers are super obvious, but did you see any way to maybe analyze what we're looking for in the answer choices or use the answer choices to narrow things down for you at all? It's kind of a mess, right? What if I went to estimate here? Okay, sorry, James, you're saying you want to eliminate D, why? Oh, okay. So the on the bottom, I have even numbers. And so maybe I don't want all odds, but I'd have to think about, do all the even numbers cancel out, right? And that's what I think you might think about more broadly in general, right? On the bottom right now, I have five, and I have some twos, and I have some threes. And so in theory, I'd have a multiple of all of that. I'd have a multiple of whatever, 6 times 5 is 30 on the bottom, but I don't. So clearly a lot of it simplifies down and cancels down. So I might think about what ends up being left. If I look at the fives, there's none that have a five in the bottom. So clearly the fives must cancel out. I don't have to think about that. In other words, I can work out how many powers of everything there are in here, but I know the fives must go away. There's no five in the bottom. Whereas the twos and threes are up for grabs. I could have just two. I could have just three. I could have two twos. I could have a two and a three, or I could have two twos and a three. So they basically told us at most you're going to have two twos left, and at most you're going to have one three left. That's if it's A. And it's very possible that you're going to eliminate more than that. Also, a lot of these factors are going to cancel out. So I can't just say, here's what I have on the bottom, and so therefore it has to be there, because then the bottom would be really large. But I can sort of see some limitations on what's going to be there, and that might help me figure out a plan. I can, of course, just do all this out in various ways, and we can look at a couple ways to do that. But what if I want to estimate just for a second? How would you go about estimating the value of just the first very first fraction? Roughly, what's that going to be, and how do we know? Generally, when I'm trying to like compare or combine two different terms and they're written very differently, I want to try to make them match better. So I might want to write the bottom as a square root, or try to rewrite the top as a non-square root. Um, that latter one is a little harder, although I might estimate. I might say, hey, I know that square root of 9 is 3 and square root of 16 is 4. So the top is in between 3 and 4. So that already tells me something. I've got somewhere between 3/5 and 4/5. So somewhere between 0.6 and 0.8. So that's interesting. Um, but wait a second, is that right? What if I do it the other way? What if I write the bottom as a square root? What would that be? If I write the bottom as a square root, it's the square root of 25, right? Do we buy that? So very roughly, what's the value of that first fraction going to be? Somewhere in the neighborhood of a half. So it's weird. I used two different estimation techniques and got two different answers. And that suggests that, maybe I'm doing something that's not quite perfect, right? But I don't have to be perfect. I don't even have to be 100% correct to start getting an idea that I know this is somewhere in that neighborhood, right? Um, okay. So then I might think, oh, did I put 5.5 or one half? So then I might think about, does it get bigger or smaller as I go along, right? What about this second one, root 60 over 2 to the fourth? What's 2 to the fourth? Okay, it's 16. So I got root 60 over 16. And roughly what's that going to be? The square root of 60 is in the neighborhood of 8. So this sounds like it's about a half. So I'm already getting down to like a quarter. And then I have to think about, what else I have elsewhere. So these processes aren't quite perfect, and I'm not doing all the math really precisely and carefully. And it might be giving some of you hives if you're used to doing things more precisely. But trying to narrow down and say, what do I have, makes me think, for instance, it's probably not one half, right? It seems like I'm already too small for that. And that's definitely worth thinking about. Okay. So then, if I want to do it more precisely, I could start thinking about what's going to cancel. Um, so how can I do that? Well, I might just write out what I have on the top if I break this down, right? So what are the factors of 12? What does 12 break down to? I'm going to do it like this. I'm going to draw a big root up here. So on the bottom, I'm going to have 5, 2, 2, 2, 2, 3, and 3. What's in 12? 12 is 3, 2, and 2. What's in 60? You might know 60 is 5 times 12, so that's interesting. In fact, if I'm feeling lazy, I could just call this 12 times 12 times 5, but for now I won't. I'll say, okay, times 5. And then 45 is 3 times 3 times 5. Now I know that the 5s are going to have to cancel out because none of the answers have a 5 in the base. And so again, I can sort of cheat off the answer a little bit and say, all right, if there's not a 5 in the base, how do I make the 5 go away? What is involved in canceling this 5 out? I got to cancel 2 on the top because to pull something out of a radical, you take 2 of them, right? So this is like the square root of 25, which is 5. So there's a little bit of danger here. When we're talking about being accurate, you could say, well, this is a little sloppy. I'm kind of trying to do things that don't quite, match up. Okay. Well, um, as long as I have consistent in my rules, though, I can sort of get used to doing, okay, I'm going to have 2 here and 1 there. And I'm going to have 2 here and 1 there. And if I say, okay, I don't have any more 2s right there, I could say I have to have 2 2s in my bottom. So it's either 12 or 4. Now I can get rid of this and this. And then I just say, okay, do I end up with a 3 or not? Well, let's see what happens. I go in and say, all right, I got a couple 3s here, and that goes, and a couple 3s here, and that goes. So I ended up just doing the whole problem out, right? I'm left with just 2 2s on the bottom. My answer is C. Not, in my opinion, super obvious. Um, but organizing how we do it, I think, is really important. And this might not be your way, right? This might not be your way, but I think finding a way to make them match up still makes a lot of sense, right? If you wanted, you could keep it more straight by squaring all the terms at the bottom and putting them in roots, right? You could do that kind of thing too. You just got to make sure that you have a way that's matching them up. Okay, let's do another one. Here's a mess. I hope you know that you're not going to be finding what 177 to the 28th is. If you know how to do that, please tell me without a calculator or a computer, honestly, because even a calculator would be blowing up on you, right? So clearly we're not doing that. But there's got to be something else. Maybe you have some ideas. So take a moment to look it over. Okay, so any ideas? If we look at the answers, first off, we know it's just going to be a unit digit. It's going to be a number from 0 to 9, and we've got 5 of those numbers listed. Anything we know about that unit digit before we, start trying to do a lot of work? Um, so we might look at just what happens when we subtract. This might feel too good to be true, but yeah, patterns of the powers of 7 and 3 just seems to be an odd and even. Good thoughts, right? So what if I just did 177 minus 133? Okay, well, that's clearly not going to just be the answer, but it's interesting. That ends in 4. And it seems probably too good to be true that the answer is just 4, that you don't have to raise it to a power at all. But I don't know. It's possible. At least I see that using these kind of numbers, I can get an answer of 4. That's interesting. What happens if I square 177 now, right? What if I raise it to a power? And again, these are, I can't do the actual powers, but what if I do that? 177 squared minus 133. Well, I don't know what 177 squared is, but I'm only asked about the units digit. What will the units digit be? Let in 9, because when I do 7 times 7, that's 49. And what's important to know, if you haven't seen a problem like this before, it might not have, come around to you, that the units digit is the only thing that affects the units digit of the answer, right? This part right here is it, because I'll carry the 4, and then I'll do this operation 49 plus 4, 53, and carry the, blah, 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 all that. But then when I come down to this number, I'll put a 0, and here I'll put 2 zeros. And so the only thing that's going to affect the units digit is the product of the units digits. So anything that ends in 7 times anything else that ends in 7, or another way to say it is anything that ends in 7, when you square it, is going to end in 9. So we'll have blah, 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 9. And then if I take away 133, I'd have something that ends in blah, 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 6. Okay, so 6 is a possible answer. 4 is a possible answer. If I now take this thing that ends in 9 and multiply by 7 again, I get a number that ends in what? 9 times 7 is 63. So I'd have a number that ends in 3. So I could have, if I do 177 to the third, minus 133. And I know I'm not subtracting 133. I know I'm subtracting 133 to the 23rd, but baby steps. I'd have something with 3 minus 133, and it's going to end in 0. So what do all those answers have in common? Two of them are there, and one's not there, but what do they all have in common? 4, 6, 0. Even. Ooh, interesting. Out, out, out. Why do we know the answer must be even? Well, think about 177 to the 28th power. If I take an odd number and raise it to a higher power, is it ever going to turn even? Even means you're a multiple of 2. This isn't a multiple of 2. You can't get a 2 just by multiplying. I could get a 2 by adding. If I add 1 to it, it'll be even. Add 1 to any odd number, it's even. But this will be odd. And this will be odd, right? An odd number to a power. So if I subtract 2 odd numbers, I get an even. Has to be C or D before I do any work. Then I can do all the work, right? The idea of this is that there are patterns, right? For 7s, if you keep doing out, you get 7 to the 1 ends in 7. 7 to the 2 ends in 9. 7 to the 3 ends in 9 times 7, so you get a 3. 3 times 7 gets you 21, so it ends in 1. As soon as you get to 1, you're back to the beginning, right? Because you do 1 times 7, you're back to the start. And every single units digit will create a pattern of 1, 2, or 4 repeating terms as the powers go up. So some are always the same, right? Think about 5. 5 times 5 is 25. 25 times 5 is 125. 125 times 5 is 625. If you take a number that ends in 5 and raise it to powers, your number will always end in 5. Other numbers are binary. They flip back and forth, like 4, 4 times 4 is 16. 6 times 4 is 24. 4 times, 4 gets you back to 6, and like that. But for 7s and 3s, you have actually two complementary patterns. 3 times 3 is 9. 9 times 3 is 27. 7 times 3 gets you 21. So we have this. So the specific math here is less the point, but we can basically say, okay, I'm going to have groups of 4, 177 to the 4th, 8th, 12th, 16th, 20th, 24th, 28th. It's going to be the end of a pattern. And this one is going to be 3 into the pattern, 4, 8, 12, 16, 20, 21, 22, 23. So I'll have a number that ends in 1 minus a number that ends in 7. Don't reverse those, right? You'll have a 4, right? Like imagine like 101 minus 97 or something like that. You'll have blah, 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 blah. 4, 1, blah, 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 7. When you subtract, you'll have to borrow and you'll get 4. So I have a slightly clearer slide of that, but it's kind of funny that the answer ended up being the thing that we would have done if we just subtracted them. I can't say that you can rely on that. That just happened to be, there's not an easy way to prove that that would be true, right? But it's just about finding the pattern. And so if you saw this, if you knew this, great. But to me, I'm less concerned about this particular bit of math and more, how do we use the answers to narrow things down, right? Also watch out when you find a pattern, don't make the pattern 5 things like this. 79317, you say, oh, when I get to 1, I'm going to start over again. The 7 is the beginning of the next pattern. Just like I couldn't say there's 8 days in the week: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, right? No, right? Monday begins the next week. However you want to count it. And so it's the same thing with these. There'll be 1, 2, or 4, and that's another way I catch my accuracy. If I find a pattern that's 3 terms or 5 terms, then I happen to know that there aren't any, and so I check my error. Okay. Let me give you one more mess of a problem, and it is pretty ugly. So once again, take a moment to look it over. It's clearly going to involve some algebra here if we want to do it out, because the answers are so involved. But maybe before you write a lot of stuff down, you might just think about, what do I expect to see in my numerator, in my denominator? Where do I expect to see these pieces go? What does X% look like? What does Y% look like? What does of mean? Maybe I could interpret some of this so I don't have to do all the work. So take a moment to Okay. So let's think for a moment about this business of X% of Y% of Z, because that looks pretty ugly. But what should that make me expect to see in my answer if I take X% of Y% of Z? What is that going to look like if I just think about that part? So I've got 2%, so I'm going to have 100 times 100 on the bottom. Now I might or may not cancel some of those hundreds later, right? But what about on the top? Okay, I'm going to multiply X and Y. What about the Z? Do I multiply that too? Yeah, if we want to write it out, the way to translate, and I think having this being very mechanical in your mind is really helpful. The way to translate percents is very direct. If you see the word percent, put whatever you talked about over 100. So 30% is 30 over 100. 90% is 90 over 100. 140% is 140 over 100, or 1.4. We might not always do that, right? If I might just write 30% as 0.3, but I can always write it over 100. X% is X over 100. So percent means divided by 100. Of means times. If you don't have that memorized, put it on a flashcard, memorize it. x% of y% of z. So if I look at just that part alone, I'm going to have x, y, and z multiplied together. And I'm going to have that over 100 squared. Now I'm taking away y% from that. So that's going to change the answer. It's not going to be that answer, right? Otherwise, it wouldn't be reduced by y%. But I might think about a couple things. One, are any hundreds going to cancel? Is there a reason to have fewer hundreds on the bottom than what I have now, like this one? But also, am I going to get rid of anything from the XYZ? Notice that some of these just take away y, but they've done a strange thing. Like they've taken a y, they've divided a y out of here, but they've also subtracted a y. Are those both going to be correct at the same time? Am I really going to divide out the y from here and subtract it? That seems kind of strange. It seems like once I've multiplied x, y, and z together, those are going to stay together. It seems like I need one of these. Can we agree on that? That once I've got x, y, and z together, I might pull some stuff out, but I'm probably going to have that core. And so especially if I'm in a hurry, and I would argue that most people should not do this problem, right? In other words, if you see this problem in the test, unless you're getting a really high quant score, you probably want to say, let me narrow it down a little bit if I can, but if not, I'm going to bail on this question. I do not want to spend 5 minutes doing this. I don't want to spend 3. So from there, then I might say, one of them is taking away y times something, and one of them is taking away just y. That might give me a good reason to choose A, but I could also think out like what it means to decrease something by y%, right? So what if I do something more concrete, like $100 reduced by 30%? There's 2 ways I could write that. The way most of us would probably do it is 100 minus 30% of 100, right? Or if you like, 30% of 100. So the hundreds happen to cancel here because I made it. Maybe I should actually make it a different number to make it clearer. Call it 200. So I don't have the same number. Okay, and that's a good idea when you're picking numbers on percent problems. Make sure you're not mixing up things that they're going to look the same when they're not supposed to be. So I could have something like this. So then I'd end up taking away $60, right? Or I could say, hey, it's 200 times 70%. Or times 70 over 100, right? Those are the same thing. So in this one, I could say, hey, I'm going to have x, y, z, but I don't know how to do really directly the version of 70%. I don't know what the rest of what you have left is when you take away y% because I don't know what y is. So I can't easily say, oh, I'm going to multiply it times, q% or whatever. But I could say, hey, I'm going to take away y% of that same thing. In other words, so just like I did with the $200 price reduced, I could say, hey, I'm going to take my value that I wanted, and I'm going to reduce it by y% of that value. And if you do that, you can see you're going to end up with something much more like A. You're going to have XYZ by itself over a fraction minus XYZ times Y over a fraction. And notice this gets you that term. Okay. So that would be probably enough for me to stop and say, hey, it's A. You could also write it the other way. The equivalent of the 70% thing is to say XYZ times whatever 100 minus Y is over 100. And I think that's the easiest way to do this problem is if you recognize this form, right? That if I'm going to take away 30%, I multiply by 100% minus 30. If I'm going to take away Y%, I multiply by 100 minus Y as a percent. And so then this turns directly into what we want. We say, okay. Oh, sorry, I still had to have this. Over 100 squared, don't leave that out. But notice even if I made that mistake, even if I forgot my denominator right here, I'd still have the top that matched, and that would give me a clue of what I wanted. So I'd say, hey, on the top, I have 100 XYZ, and then I'm going to take away 100 XY squared Z. And so then even if I made a mistake with the denominator and just add 100, I would say, okay, the top looks like A. That would give me a chance of where to look for my mistake because I make mistakes all the time. I'm sure you do too. And so we look for those ways to catch them. And thankfully, there's not all there, right? If there were an answer that looked like A and another answer that said 100xyz minus xy squared z over 100, then if I happen to have made that mistake, it would be there. But A, the GMAT didn't know I was going to make that particular mistake. And B, they don't. They're sometimes actually nice. They don't always just put all the mistakes we would make as answers, even if they're likely mistakes. And it gives us another chance to catch what we're doing, and that's part of the again of the beauty of multiple choice. Okay. Um, so I can write a more thoroughly written out version of this if you want to see it. But I'm often trying not to do this kind of stuff if I can. And so analyzing sort of positionally and say, hey, I want to have an X, Y, and a Z together on the top narrows it down enough, or I might stop there. Okay. Well, I hope this is helpful to you. I mean, the biggest thing I would say is just always look at the answer choices for ways to think about what's a way into the problem. What are some reasonable answers? What can I expect to see? Are there ways to narrow it down, to estimate, to work backwards, to get even a single sense of what the trait of a right answer is supposed to be? And look for that even on problems that you find easy, even on problems, or maybe especially on problems that you find easy, where you know how to do the work. Because if you can spot your way through, in review, especially on a problem that was easy for you, then next time you might be able to spot your way on a problem that's hard. And that's really where we're winning most support. Sure, James, you just mean the slide we were just looking at, this one? Oh, the one where we were solving with all the, I can put the work back up there. Let me know if you have a question. And if you don't have a question, then I would love to see you in one of our classes. So I'll put this back up in a second once I'm done with the recording. But if you want to check out any of our classes, you can attend a class live. All the classes are free to try the first session. You can also check out our interactive options as available. If you want to see a list of our upcoming classes, at the moment we have classes for both classic and focus versions of the exam. So I'd love to see you around. Stick around if you have questions or if you'd like to see anything else. Other than that, best of luck with your test and hope everything goes well for you. Take care.